Okay, so let's take a look at the characteristics of the graph of the parent function f of x, which is equal to the log of base b x. Now for any real number x and constant b is greater than 0, meaning the base, and base cannot equal 1, we can see the following characteristics in the graph of f of x, which is equal to the log of base b of x. Well, we can notice that they're both one-to-one functions because it passes the horizontal line test. Okay, the vertical asymptote is going to be x equals 0. The domain doesn't go across to the negative side, so it only starts at 0 and goes to positive infinity. The range is going from negative infinity to positive infinity. We have an x-intercept at 1, 0, and then we also have a key point, which is b and then 1. So that is the base and then the value of 1. We do not have a y-intercept because it doesn't cross the y-axis. The logarithmic function is going to increase if the base is greater than 1, and it's going to decrease if it's in between 0 and 1. Now, if you look at this figure here, it's going to show how changing the base b in f of x, which is equal to a log of base b x, can affect the graphs. Observe that the graphs compresses vertically as the value of the base increases. So here it's increasing. And if you recall that the function, the natural log of x, has a base of e. So in example 3, we want to be able to graph a logarithmic function with the form f of x, which is equal to the log of base b of x. So given a logarithmic function of that form, first we're going to draw and label the vertical asymptote, which is x is equal to 0. Number 2, we're going to plot the x-intercept, which is 1, 0. And then we're going to plot the key point, b, 1. And then we're going to draw a smooth curve through the points. And then we're going to state the domain and the range and the vertical asymptote. So for example 3, we want to be able to graph f of x, which is equal to the log of base 5 of x, and state the domain, range, and the asymptote. Now before graphing, we want to be able to identify the behavior in the key points for the graph. So the base of this logarithmic function is 5, it's greater than 1, so then we'll know that this function is going to be increasing. Now the left tail of the graph will approach the vertical asymptote x equals 0, and the right tail will increase slowly without bond. So you look here, we're going to create our first vertical asymptote, so we have x is equal to 0. We also know that the x-intercept is 1, 0, and we know that a key point where the base is 5 and the value of 1 is on the graph, so we know that 1, 0 is on the graph, which is the x-intercept, and we also know that 5, 1 is on the graph. And then we're going to draw and label the asymptote, plot and label the points, and then draw a smooth curve through the points. So we know that it is an increasing function, so we know it's going to start here at this asymptote, and it doesn't cross the y-axis, so that line should be just over a little bit more. And then it connects those points and then tapers off.